It is the last section. Okay, so 6.6, De Morph's theorem. All right, so this is the last kind where we are writing something in terms of something like a vector. And that is complex number. Do you guys know what complex number is? Yes, it has to do with I, and that is in the form of A plus BI, where A is the real part, and then BI is the imaginary part. So we're going to take that complex number and we're going to put it on the complex plane. And one more thing. When we talk about complex number, there is a kind of, so in the number world, there are letters that represent the numbers. So complex number is called Z. So if they say Z, that usually just means it's a complex number. Okay, so they want you to plot the complex numbers as vectors, so make it look like vectors in a complex plane. Complex plane, we have never talked about this, but it's pretty easy. Complex plane is kind of the same idea as XY, except it's not XY. It's going to be real versus imaginary. Real versus imaginary. So remember, the real part is the A part, and the imaginary part is the B part. So for example, U. Notice how it's not bolded. It's not a vector anymore. It's just a number. This number is 1 plus 3i. 1 plus 3i. 1 plus 3i, then the A part is what? 1. And then the BI part is 3. 3i, correct. So then what we do is we go 1 in the real part and then 3 in the imaginary part. And then this is my vector in a way. This is 1 plus 3i. So kind of think of it as 1, 3, like in the vector world. But in the complex plane, the x part is the real part, and then the y part is the imaginary part. Okay, let's try another one. V. 2 minus I. 2 minus I. So that's going to be 2 in the real and then negative 1 in the imaginary. So this is going to be 2 minus I. Now go ahead and show me what U plus V is. If you were to add U plus V like two vectors, how would you do that? And how would you show me that in the complex plane? All right, if you recall, so if you are trying to add U plus V, then you move V to the head of U. And so you would do this. And then the resultant vector is from the tail to the head, like that. So this is the resulting complex number, which is 3 plus 2i. If you kind of think of it as a vector, everything is pretty similar. So the next thing is this absolute value looking thing, but it's called modulus. It's not called magnitude, it's called modulus. So if they say, what is the modulus of the complex number? It's basically the length or the magnitude of the vector. And they would write it like this, like an absolute value z. Z, remember, means complex number. That is kind of like this, a plus bi. Basically, it's asking for the length of that vector, and it's going to be the square root of a squared plus b squared. So we're going to break down this complex number vector into its component form again, just like a vector. So let's say that this is my complex number vector, and this is the real part, and this is the imaginary part. And there's some angle in between. So if this number is a plus bi, and then I am drawing a straight line down again, creating a 90 degree, then the question is, how long is this part? You can think of it as a projection, but just how long is that part? If that vector is a plus bi.
A plus bi cosine theta.
Too far? Just that part. How long is it? A. Just that part. A. And then how long is this part? B. It's just B. Okay, now this vector has a radius r, just like before, like when we talked about vectors or when we talked about, what did we just do? Polar. It's just kind of the same thing. So we would say A is the same as, this is the time you say that answer you told me before.
A plus bi cosine squared. No, I mean cosine.
The cosine theta is right, but we forgot a number in front. R, yes. R cosine theta. And then B is the same as, yes, R sine theta. Okay, now, because Z is the complex number. Complex number is A plus BI. Therefore, we're going to put the R cosine theta in A, R sine theta in B. So this is going to be R cosine theta plus R sine theta I. So what I'm doing is I'm taking a complex number that has A and BI, and I'm breaking it down to radius and angle. Does that make sense? So A plus BI is the complex number. I'm breaking it down into R and theta, which is a different form of that same complex number. But usually, so this is the way I learned it in high school. This is too long to write. So what they told us to write was this form, RCIS theta. So how does that work? You see how there's the radius here? CIS means cosine, I sine, and then angle. So it's just easier to write that instead of the whole thing. R cis theta, something like that. Okay, so let's kind of organize all that information. So this R cis theta form is called the trigonometric form. So this is where we got a lot of forms. I know I haven't really tested you on the forms, but if you kind of recall from before, there was like, what forms did we have? Linear combination, there was the component form, yeah, there was some other ones. And then now we have this trigonometric form. So trigonometric form is Z equals R cis theta. And just to recall, R cis means R cosine theta plus R sine theta with a I. And then we know that A is R cosine, B is R sine, R is the square root of A squared plus B squared, and we can find theta just the same way as before, the direction, angle, and all that stuff. But there's another name for all this stuff. So they don't quite call theta the direction angle. Sometimes they will call this the argument. They would say the argument of Z. Z, again, means complex number. And just a reminder, R is always positive because it's a length. All right, let us apply. Okay. You guys copied everything down, kind of? Yeah, okay. Okay, write a trigonometric form with theta is between 0 to 2 pi for the complex number. Okay, so 1 minus square root 3i is the complex number. They want you to write this in trigonometric form. Trigonometric form means you have a r and you have a theta in R cis theta form. So same thing as before, we're going to have to graph this in as a vector so we can see where that vector is. Okay, 1 minus square root 3i. 1 minus square root 3i. So that's going to be 1 here and square root 3 here. So that is a vector going down like this. We need to find the r, and we need to find the theta. All right, go ahead and do that. All right, r is going to be the square root of a squared plus b squared. So that is 2. You guys got 2? Okay, the angle, we have to first find this angle. That's the reference angle. So that is, what is this? 1 and square root 3. So tangent of the reference angle is opposite over hypotenuse. So that angle is the inverse tangent of square root 3. Inverse tangent of square root 3 is going to be, yes, in that area. So, but pi over 3. Yes, pi over 3. Okay, so then that angle from the 0 degrees is going to be 5 pi over 3. So far, so good. So same stuff as before. We've been doing this radius angle for a while now. Okay, the last thing we're going to do is write this in trigonometric form. So r cis theta. So 2 cis 5 pi over 3. Okay, so changing from 1 minus square root 3i into r cis theta is 2 cis 5 pi over 3. Yes, you have a question.
How'd you get 5 pi over 3?
Okay, this reference angle here is pi over 3. So we want the reference angle from the 0 degrees. So basically the whole circle is 2 pi minus, okay.
So 2 pi minus.
Okay, how do you know that you got the right answer? How can you double check? Well, we can go backwards. So 2 cis theta, 2 cis pi over 3 is the same as saying 2 cosine 5 pi over 3 plus 2 sine pi over 5 pi over 3 I, right? And what you need to do is just multiply this whole thing out. Okay, cosine 5 pi over 3 is what? 1/2. Yes. And then sine 5 pi over 3. Yes. Okay, so 1 minus square root 3i. Same thing. So then you know you got it right. So going back and forth from complex number to trigonometric form and trigonometric form back to complex number. Okay, it's really just another way of writing this whole thing. And you may be wondering, why are we changing it if there's, we just want to know this one point is space. That's because later on when we do want to add some complex numbers together or multiply them together, it's actually easier when it's in this form than doing it by complex number. But anyways, we'll get there together. All right, let's try this one. This one, it is not in a unit circle, so you do need to use your calculator. And again, please keep the angle positive. Okay, the answer, I have this all in degrees, but you can have it in radian if you want. 5 cis 1 degrees. Okay, next. Let's say we are trying to multiply complex numbers together. Multiplying complex number is pretty easy. You've been doing that since Algebra 2. But if we are going to multiply them together in trigonometric form, they have a different formula. You don't need to memorize the formula. I will give you the formula on the test because they're just a very, very small section of your chapter. So, not necessary to spend a lot of time memorizing. Okay, Z1 times Z2. The formula is R1, R2. R1 is the radius for the first number, and then R2 is the radius for the second number. So R1, R2 times cosine of theta 1 plus theta 2 plus I sine theta 1 plus theta 2. Okay, so we're just kind of learn how to apply the formula since we're not memorizing it anyways. If we're going to take z1 divided by z2, that's the two complex numbers divided by each other, then we take r1 divided by r2, and then cosine of theta 1 minus theta 2 plus I sine theta 1 minus theta 2. And then just a reminder that the shorthand for r cosine theta plus I sine theta is r cis theta. Okay, so now we're just going to learn how to apply the formulas. So use the algebraic formula to express the product of z1 and z2 in standard form. Standard form. So they don't want this in trigonometric form, they want this in standard form. However, they give us the complex numbers in trigonometric form. So we're going to find the product. The product is z1 times z2. So according to the formula, I'm going to take the first radius times the second radius, and then I'm going to take cosine of the first angle plus second angle, and then plus I sine of first angle plus second angle. All right, this is just a direct application of the formula. It's nothing really special. Take the first radius times the second radius, so 25 root 2 times 14. And then cosine of first angle plus second angle, so negative pi over 4 plus pi over 3 plus I sine first angle plus second angle. Okay, we're just going to simplify the whole thing until it becomes a standard form. Okay, so let's simplify this. 25 root 2 times 14 ends up being 350 root 2. Cosine of, and then negative pi over 4 plus pi over 3. Pi over 12, so cosine pi over 12 plus I sine pi over 12. Okay, that's good, but that's still in trig form or trigonometric form. So how do we turn this whole thing back into a complex number or standard form? Huh? No, this is r cis theta, which is the trig form. We need to get it into a plus bi form. Yeah, just multiply the whole thing out. Just multiply the whole thing out. So basically 350 root 2 cosine pi over 12. That's going to be 8. And then plus 350 root 2 sine pi over 12. That's going to be the bi part. So you use your calculator, and then if you multiply the whole thing out, that's going to give you the a plus bi form. Okay, the answer is 478.11 plus 128.11i. Okay, this is the standard form. This is the a plus bi form. So we're changing back and forth between a plus bi and the trigonometric, the r cis form. Okay, let's have you practice one. Find a product. All right, this next one. So this is, again, just an application of the formula. It's just negative 12.684 plus 5.922i. Okay, now we're going to practice dividing. Sorry, this should be the quotient. Okay, I'll use the algebraic method to express the quotient of z1, z2 in the standard form. Okay, standard form again. All right, so z1 over z2 according to the formula. So since you have the formula, I'm not going to write it again. The formula says radius 1 divided by radius 2. So radius 1 divided by radius 2 of cosine of first angle minus second angle. First angle minus second angle plus I sine first angle minus second angle. And then just simplify all that again to get it into a standard form. This is negative 0.46 minus 0.12 I. Yes? Okay. Yes, question? No.
Oh, wait, never mind.
Okay, let's kind of explore a few things. Let's say that z is this trigonometric form here. Z squared. Let's find z squared. Z squared is the same as saying z times z, right? Z squared is the same as z times z. So we can use the product formula. So z is r cis theta. According to the formula, if we're multiplying two complex numbers together, what do we do with the radius? They multiply, so this becomes r squared. Okay, and then we have cosine of, what do we do to the angles?
2 theta.
We add them together, so it becomes 2 theta. And then we do the same with the sine. Is everybody okay with this part? Okay, I'm just multiplying two things together. That's exactly the same. So I multiply the r, I add the angles according to the formula. Okay, take it one step further. We're going to now find z cubed. Z cubed. Z cubed is the same as saying z times z squared, or z times z times z. But we already found z squared before, the previous one. So we're just multiplying z times z squared. According to the formula, again, what do we do with their radius? They multiply. So this becomes r from the first one, r squared from the z squared, so this is r cubed. Are you guys with me? Okay, and then cosine of the two angles added together. From z, the angle is theta. From z squared, it's 2 theta. So you add it together, you get 3 theta. Okay, 3 theta plus I sine 3 theta. Okay, last one. Z to the fourth. Z to the fourth is the same as saying z times z cubed, or we can say it's z squared, right? Let's just say z squared times z squared. Okay, so according to the formula, what do we do to the radius? Multiply, so z squared times z squared becomes r to the fourth. And then cosine, we add the angles together, so we get 4 theta. And then plus I sine 4 theta. Okay, now notice, what pattern do you see? R to the n. Okay, so if we say r to the n, not r to the n, z to the n, z to the n would become what? R to the n, cosine n theta, plus I sine n theta. Basically, we see that the power has to do with what the power is with the radius, and then how many times the angle we have. So this is called the De Mor's theorem. It says, if you are trying to multiply this complex number and you raise it to some degree, you can do this really quickly if you just follow this formula. And then we'll apply this formula on Monday.